but I'm sure you'll see a lot of this guy. We are homesick. Oh, please don't draw on my arm. Okay. We skipped, because I haven't been there for a couple days, I'm so sorry. We skipped this little part of the notes, and I think it's important you understand it because this has to do with what we're doing today. So this is kind of the application of all that we've been doing, these kind of trig identities. First thing I want to do is define angle of elevation, angle depression. So I'm going to draw with, I didn't bring my pencil. We'll see how it goes. It's a great circle, buddy. So let's say we have a person who is laying on the ground right here. And they're looking up at the sky, and there's a tree right here. Beautiful tree. There's a bird up here in the tree. Oh no. So this person is looking up at the bird like that. This angle, so he's laying on the ground. This angle up here from the ground all the way up to the bird, whatever object he's looking at, is called the angle of elevation. So the angle, this is going to be so bad because I'm just writing with my finger. From horizon to object, basically. This angle from just straight out from the ground all the way up to the object you're looking at. The angle of depression would be more the bird's point of view. So if you're the bird up here, this is straightforward. The bird's now looking at the person. So they are looking straight and they go down to look at the person. That is called the angle of depression. So this angle right here, the angle from straight all the way down, is the angle of depression. That's important to know. So I guess I can write that here. Angle from horizon. Angle or horizontal to down to an object. Okay, I don't know where all that went. Hopefully you got that. So angle from horizontal down to object. Okay, it's important to know because sometimes when we have questions here, they want you to know what those things mean, and if you're not sure which angle they're talking about, when you're setting it up, you're going to be confused. I like these questions because this is honestly like the realistic part of life. The reason you would actually be using the trig identities. You're not going to be in real life and be like, okay, I've got a random triangle. I'm trying to find, this length of side. This is like what we actually use this stuff for. So let's look here at example 6. I'm sorry, this is like the most scatterbrained video ever, but hopefully it's helpful for today. So example 6, you've got a builder constructing a wheelchair ramp from the ground to a deck of a height of 18 inches. So picture your mom is getting old. You don't have the money to hire someone to build her a ramp. You've got to build it yourself, and you can't waste any money. So let's draw this out. We've got, we've got the ground right here. You've got your deck right here. Her wheelchair can't get up. It cannot get up to the deck. You've got to figure it out. So, do you want this on or off? So you've got to figure out how to make this ramp right here. We know that the deck is 18. We know that the deck is 18 inches. So that means this height right here, 18 inches. The angle between the ground and the ramp has to be 4.8 degrees because she can't go up anything steeper than that with her little arms. 4.8 degrees. To the nearest inch, what should the distance between the end of the ramp and the deck be? Okay, end of the ramp right here and deck right here. So we're talking about this horizontal distance right here. We want to know what that is. So if we make like just a normal triangle and you're going to draw this out, you're going to have this angle is 4.8. We're going to have this side is 18, and you need to figure out this side right here. So I want you to think through, I think sometimes figuring out which things to use is kind of the trickiest. A thing to remember is this. If you have all sides, like you're missing two sides, you need to find a third side. That's when you use the Pythagorean theorem. You don't have any angles involved, you just need to find sides. However, when you've got angles and sides, that's when you're going to use your trig identities. So, if you remember, I know on the board I have sine and cosine written, but not tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I want you to look at your angle. Obviously, we've got an angle there, so that's going to go in for theta for whichever of the things we use. But if you look at this angle right here, can you tell that we've got opposite? So 18 is opposite, and we have adjacent for x. We don't know what the hypotenuse is, and we don't need to know. So if we've got those two sides, if we've got opposite and adjacent, I know I'm going to use tangent because those are the two sides that are involved. So I'm going to write this down. Remember, tangent of theta equals opposite over adjacent. I put them away. Tangent. Sorry. So the tangent of the angle is 4.8 equals. We're not going to cut your paper. No, we can cut it later. Equals opposite, so that's 18 over x. Now your job is just to solve for x. So I am going to scroll down a little bit so we have more room with my giant finger writing. Okay, tangent. Oh, it doesn't want me to write over here. I don't know what it wants. Okay, so you've got tangent of 4.8 equals 18 over x. We need to solve for x. We need to get x by itself. Okay, x is in the bottom. That's a little bit of a problem because if we want to know what x is, it needs to be in the top. So let's take x and multiply both sides by x just to get it out of the bottom. So I'm going to do times x and times x on both sides here. So the x in the top and the x in the bottom will cancel out. You're left with 18 on that side and x times tangent of 4.8 on this side. Okay. Now, again, you need to get x by itself, so we're going to divide both sides by tangent of 4.8. Tangent of 4.8. And you're left with x equals 18 divided by the tangent of 4.8. This is just the stuff you have been doing in your practices. So you should be able to plug that in your calculator. Let me see if my phone calculator wants to do this. I don't know if the phone calculator has tangent, and I don't want to stop to look. So we're going to come over here. We're going to go to Desmos. This is an online calculator. And we are going to start trying to type it in. Okay, you always want to check your settings to make sure you're in degrees rather than radians. Always do that because you'll get something weird otherwise. So we've got 18 divided by the tangent of 4.8. Oh, sorry. 8. And you get 214.4-ish. So let's go back over here. So the answer right here is 218.4 inches. That means from your deck, you need to measure out 218.4 inches. That's where you're going to start building your ramp. If you need to know how much wood you need to get, you should look at the hypotenuse. Solve for the hypotenuse. You can just get a piece of plywood that long, place it that far away, and your mom's going to be set. Okay, let's do this last one. I'm going to erase this. I hope that you can just rewind and write it down if you want it. Hello, sir. Okay, so let's talk about this last one right here. Angle of elevation. So, okay, this is a little bit confusing when you're reading it. I understand that. Let's work through it together. Angle of elevation from a point 340 feet away from the base of a building to the top of a building is 65 degrees. What is the height of a building? Okay, first of all, I know there's a building, so I'm going to draw a building. let's see. We'll make it a blue building right here with 4 windows. Okay. I know that I need a point 340 feet away from the base of the building. So I'm going to draw in some grass here. Right here, we're going to say is 340 feet away. It says the angle of elevation from a point, from this point right here to the top of the building is 65 degrees. So I remember angle of elevation, look straight out and go up to whatever you're looking at. So what we want to look at is the top of the building. So it's going to be this angle right here. This angle is 65 degrees. It wants us to figure out the height of the building. So this side is X. Again, I want you to look at, so we've got angles and we've got sides, which means we're going to use the trig ratios. Look at what sides we have and what we need to find. That's going to help us figure out which ratio to use. So if this is our angle, we need to find opposite, and we have adjacent. Opposite and adjacent, that means we're going to use tangent. So I'm going to write this out. Tangent of theta, which in this case is 65 degrees, equals opposite, so X, over adjacent, 340. Now we just need to solve for X. Once we've got it set up, that's our last thing to do. So in this case, X is on the top, which makes it a little bit easier for us. We just need to get it by itself. So it's being divided by 340. To get rid of that, I'm going to times it by 340 on both sides. Oh, it doesn't like me writing over there. 340. And we get 340 times tangent of 65 equals X. So I'm going to plug that in. 340 times tangent of 65. So 340 times tangent of 65. 729.1. So that is how tall the building is. 729.1 feet. Okay, so on your homework assignment, there are questions like this. And on your lab that we're doing today, there are questions like this. So let me kind of explain the lab, what it looks like today. So hopefully, let's get rid of that. Hopefully someone has gone and picked up this paper. Let me show you. I printed it on the back of the packet, but I realized when you cut it out, you will cut up the questions. So don't do that. Use the separate piece of paper if you can. You are going to start by making the clinometer. Let me show you what it kind of looks like. Yours is going to look better than this, but this is my homemade one. You're going to have your like protractor looking thing that you've cut out. You are going to, so the directions are right here. You cut out the protractor thing. You're going to poke a small hole right where that dot is on the, right here on this dot. Let's see. Right there. You're going to poke a hole with scissors. Try and make it as small of a hole as possible. You are going to put a piece of string of yarn through there. It only has to be like 6 inches long, not super long. You're going to tie a knot in one end. I wasn't able to tie a knot because I made too big of a hole, but I taped it. So you also can tape it. Just make sure that end of the string doesn't come through. The other end of the string should come through right here. And you are going to put a weight on the end. I used a crayon. I put paper clips for you guys. It doesn't need to be very heavy. Just something to make sure the line is straight. The last thing you're going to do is you're going to tape a straw right along, let's see, this dark black line right here. So I didn't have a straw. I just folded it over to make it like a straw, but that's what you're going to do. So that's you're starting making your clinometer. Let me show you kind of the setup to this. So at the beginning of this lab, there are a couple questions just to kind of remind you of how to do this stuff. So I want to go through them with you just so you feel comfortable. So let's do, oh my goodness, I'm sorry. Let's do this first one. I'm going to draw out the scenario here. So we've got Peter. He's standing right here. Let's see. That wasn't great. Let's do it again. Here's Peter. His eyes are right here. Okay. His eye level is 5 feet above the ground. So I'm going to label that 5 feet. He is standing 50 feet from a water tower. So water tower is over here. And this is not drawn to scale, but it's fine. There's a water tower 50 feet between them. The angle of elevation from the students to the top of the water tower is 36 inches. So basically what they're saying here is his eye line is right here, right straight out at 5 feet above the ground. So that angle between his eyes and the top of the water tower is 36 degrees. They want you to find how tall the water tower is. Okay, this is what you're going to be doing in your lab. So I want you to pay attention to how to do this. So can you guys see that this 50 feet is going to be the same as this dotted line? This dotted line is also going to be 50 feet. They're parallel. They're the same distance here. We can use our trig ratios to find this height right here. And then we know that he's 5 feet off the ground. So we know that this height right here is 5 feet because that's where his eyes are. So we should be able to do this 5 feet plus this distance we find using the trig ratios in order to get the height of the water tower. So let's do that. Let's draw out this triangle here. We've got a right triangle. This is 36. This bottom length is 50, and we're trying to find this. So again, you've got an angle. The two sides that you've got is you need to find opposite, and you have adjacent. So opposite and adjacent means we're going to use tangent. So let's draw this in. Remember, tangent of your degree or theta, whatever variable we use, equals opposite over adjacent. So tangent of 36 equals x, the opposite, over 50, the adjacent. And we just need to find get x by itself. So it's being divided by 50. We're going to multiply by 50 to get rid of it. And that leaves x by itself. So we've got 50 times the tangent of 36 equals x. 50 times the tangent of 36 is 36.3. So that means x is 36.3. But remember again, we still have that 5 feet from the ground. So we need to add 5 to it to get the full height from off the ground. So 41.3 feet is how tall it is. Okay, let's look at the second one here. We've got a construction worker setting his ladder against a wall, so the top of the ladder is resting on the top of a 12-foot roof. So, construction worker, let's make this red. Here's a wall. He puts his ladder against the wall, so the top of the ladder is resting at the top of a 12-foot. Okay, here's our ladder. 12-foot roof. So this is 12 feet. Maybe. Let's see if I can work this. 12 foot. The ladder is 20 feet away from the building. So this is 20 feet. What is the angle of elevation? So we want to figure out this angle right here. Elevation, remember, is horizon up to what you're looking at. So let's set this up. We need to find an angle. So we've got angle on sides. We have opposite and we've got adjacent. A lot of these are going to be tangent. So let's set that up. We've got the tangent of, we don't know what the angle is. So we can put whatever variable we want. We could put theta. We could put a. We could put anything. Let's put theta. The tangent of theta equals opposite. So 12 over adjacent, 20. Now we need to figure out what theta is. We need to get it by itself. Remember, with anytime we have like a trig and an angle and we need to figure out what the angle is by itself, we need to get rid of tangent. We can't divide it out because it's not tangent times theta. We need to do the opposite of tangent, which is inverse tangent. So you're going to do that to both sides. Tangent inverse. Inverse. And so that cancels. We've got theta equals the tangent inverse of 12 over 20. So let me see if I can plug that into Desmos here. Functions. Here we go. Tangent inverse of 12 divided by 20 is 30.96. So that is the angle here. Theta equals 30.96 degrees. Okay, last one here. Jeffrey's standing 20 feet from the base of a cliff. So let's draw him here. Here's Jeffrey. Here's the cliff. He is standing 20 feet away. Jeremy's eye level, from Jeremy's eye level to the top of the cliff, the angle of elevation is about 35 degrees. So let's say his eye level is right here. Follow it over. This angle from his eye level up to the top of the cliff is 35 degrees. If Jeffrey's eye level is 6.5 feet off the ground, how tall is the cliff? So we know that he is 6.5 feet from the ground. So we know that they want us to find this last part of the cliff so that we can figure out how tall it is. Okay, so basically think of this as like a triangle here. We've got 35 degrees, we've got 20, and we need to figure out this distance. Hopefully you're figuring out a pattern by now. If you've got an angle and you've got opposite and adjacent, we're going to use tangent. So tangent of 35 equals x over 20, opposite over adjacent. We need to get x by itself, so I'm going to multiply both sides by 20, and you get 20 times tangent of 35 equals x. So let's plug that in. 20 times the tangent of 35. Tangent of 35 is 14.00. So let's go over here. So x is 14. Remember again, we've got that 6.5 feet. So the height of the cliff is both the 14 and the 6.5 feet. So we need to add those together, and we get the height is 20.5 feet. Okay. Ooh, that is bigger than it needs to be. And I don't know how to make it smaller, which is fine. Okay. Those are kind of warm-up questions just to get you familiar with how to do this. Let me explain a little bit of how the lab is going to look. You are basically going to find the height of objects without actually measuring how tall they are. So you're going to start by picking a couple things in the room to test this out. Let's say you pick the projector, okay? The first thing you need to do is you need to figure out how far away from the projector you are. So just like in this question right here, Jeffrey knew he was standing 20 feet away from the base of the cliff. Bring it here. You need to do the same thing. So use your feet to try and measure this. I wish that I had meter sticks for everyone, but I don't. So Jude, bring it back now. Sorry, he's so distracting. So you're going to use your feet to measure it. So start at like the projector, the wall with the projector. You're going to walk a certain distance away from it. Let's say you go 10 feet away, like 10 steps. The next thing you're going to do is you need to measure the angle of elevation. So that's where this clinometer comes in. So I want you to stand where you're at, 10 feet away from the projector, and you're going to look through the straw. And I want you to move it up until you see the projector. Keep your clinometer where it is, and you will notice the string has fallen on a certain spot. So mine is probably like 7 degrees. Can you guys all see that? as you are looking up and down, this will change and it will show you your angle of elevation. So that means my angle of elevation is 7 degrees. So let me show you how to set this up if you were to do this. Let's say we draw a projector. Projector's right here on the wall. I'm right here. I walked 10 feet away. So this is 10. I can see my eye levels right here, and the angle of elevation from where I'm at is 7 degrees. Oh, that looks like 70. Let's get rid of that. 7 degrees. It still looks like 70. We'll just say 7 right there. Okay, you've got to figure out how tall the projector is. So the two things you need to know now are, first, where's your eye level at? And then second, you've got to figure out this length from your eye level up to the projector. That thing that we've been doing all these things to solve for. So what I'd say is take how tall you are. You can do it in, well, yeah, you got to convert it. You got to convert it to feet. So I'm 5'4". I'm going to say that my eye level is about 4 inches down from the top of my head. So when I'm saying where my eye level is, I'd say 5 feet. Oh no, I'm making it bigger. Okay, we'll put it there. So let's say this is 5 feet. I need to figure out x. So think of it as a triangle. You've got 7 degrees right here. You've got 10 feet here. And we need to figure out this side right here. You can set it up. This is tangent again. So it'll be tangent of 7 equals x over 10. X equals, you gotta multiply both sides by 10 to get rid of that. So 10 times the tangent of 7. If I'm gonna come over here, I'll plug it in. So tangent of 7 times 10 is 1.22. So that means x is x equals 1.22. And that means the projector is 5 plus 1.22, so 6.22 feet tall, which is not the case. My angle was off because I didn't have the projector to measure, but that's what you're going to do. So this first clinometer practice, you're going to pick 2 things in the classroom to do that for. Make a plan. So hopefully you can see the things that you need to know. Drawing a picture will help. So first, how tall are you? It's good to know. You need to know your angle of elevation. Can you throw it away? No. You need to know your angle of elevation, and you need to know your how far you are from the object. Those are all the things you're going to need to gather. So as you go through, once you've kind of figured out how to do it in the classroom, you're going to go outside the classroom, and you're going to find 4 objects throughout the school that you can measure the height of. This could be in the commons. Try not to disrupt anyone as you go. I am going to give you about 10 minutes, like a short amount of time. You need to write down for each thing the name of the object, the distance from the object. So go to the object, walk a certain number of feet away from it, and then the angle of elevation. Those are the 3 things you're recording about all 4 objects. So go out, do that, come back. Once you come back, this page right here is where you're going to do your calculations. So you should draw a picture in the box one, and then you will calculate it in the part below it. Then I've got some questions for you to answer about how to do this. I hope it's fun. I know that the other classes weren't so excited about it, but you're getting out of the classroom. You're actually using math. I think it's the best part of math. So hopefully it goes well. I'll see you on Monday. I'm so sorry.